Recording. Okay. Anyone still writing before I move on? Number 2. Again, we're using this pattern. It's a new pattern. We're exploring it today. Number 2. Alex, you said you think the question mark is 10?
Yeah.
10 to the power of 2. Is that 100, guys? Yes. Can you figure out the other question marks with your group right now? We'll check in about a minute. Can you figure out the other ones? Try to rewrite it with an exponential or an exponent. I'll come check. Hold on.
I mean, we kind of are.
We're doing 3 to the power of something equals 27. What's that something got to be?
No, but
Let's come back to this. 3 to the power of what is 27? What is it? What?
9. 3.
3. 3 to the third equals 27. It's okay. It's okay. We are going to get bigger numbers. We're going to learn how to use the calculator today, too. It's going to be okay. It's going to be okay. How about the next one? 2. This one's going to be 2. What about the last one? 256, because 16 squared is 256. Number 3, how can you turn the Fitts equation into an exponential equation? Try to rewrite it as an exponential equation. Label this, please. B stands for base. X is your exponent. So when I rewrite my Fitts function to an exponential equation, I'm going to have b to the power of x, and it's going to equal my y value. We're going to practice this. Okay, so b stands for base, x is our exponent, and whatever is in that Fitts function or the log is what it's going to be equal to.
Oh, I get this.
Can we fill in the question marks for number 4? 2 to the something equals 1. 7 to the something equals 1. 2 to the 0 equals 1? You're correct. 2 to the 0 equals 1. Does that hold true for everything?
Yeah. How much is that? Anything to the power of 0 is 1.
Oh, fantastic. Anything to the power or exponent of 0 is 1. So all of these are 0. 7 to the 0 is 1. 100 to the 0 is 1. B to the 0 is 1. And what I'm doing here is I'm just rewriting it from our Fitts form to our exponential form. Let's have your team look at number 5. You and your team look at number 5 now. Look at number 5. They're all 1. Let's check it out. 2 to the power of 1 is 2. Do you agree?
Yeah.
5 to the power of 1 is 5. And so on. These are all 1. The exponents are all 1. B to the power of 1 is B. What do we notice? Yes. It's okay. Anything to the power of 1 is itself, or that number. How are we feeling so far about the Fitts function?
I hate it.
Okay, well, it's really called the logarithm. It's called a logarithm, okay? What is a log? A log is the inverse of an exponential. A log is the inverse of an exponential. We're writing this down. That's what a log is. So a log function and you can say log or logarithm. A lot of students just say log for short because it's easier. So I can always rewrite my exponential form, this is exponential form, into a log form. So if I have log with base b, inside my log goes y, and out comes x. And I'm going to use parentheses because I'm going to show you how to use this on Desmos, and you do need parentheses. I think it's going to be easier if you use Desmos. So we're going to be using it today. Okay? A note when we're talking about inverses, a log undoes an exponential with the same base. So, for example, if I have log base 2 of 2 to the x, these two things undo each other. And I'd be left with what? Log base 2 of 2 to the exponent of x. I'd be left with just x. Okay, so they undo each other. Sometimes you guys like to say they cancel. They're going to cancel each other out. Yeah. And what's it equal to? X. Yeah. What's up? Because that's the base of the exponential. How about part B?
What do we do with the 2?
Where's 8.4?
I don't know.
8.4 is the base. What it's equal to goes inside the log. The exponent comes out. And so now we're ready to type this in. Now we're ready to type this in. Now in your calculators, you don't have a log change base. So if you want to use your calculator, here's what you would type in. To change the base, I might write this in a different color or something. I'm going to do log of 31.6 divided by the log of the base. Okay? So on your calculators, you all have a log button. But on your calculators, the log button always is base 10. That's on your calculator. So right now, try it on your calculator. Do log of 31.6 divided by the log of 2. And then I'm going to show you on Desmos too.
I agree with you, but we haven't tried it.
Okay. What's your answer for B?
0.27.
What? Oh,
What? Uh-oh. Did we do it wrong? Log of 2,340 divided by log of 8.4. Oh no, who told me 0.27? It should be this. That's what we should get. Is that what you got?
Yeah.
Okay, that looks better.
no.
Number three, I'm going to rewrite this. So write a hint or a step. Rewrite this in your exponential form. When you see a log and you've got to solve it, just start by rewriting. So what's the base of the exponential? 3, right? That's my base. To the power of what? 4, and it's going to equal what's inside the log. Perfect.
Would we keep it in parentheses?
Nope, it breaks out of the parentheses now. What's 3 to the 4th power? What? 81. So I can do that in my calculator. 3 to the 4th power. And now I'm just solving a one variable equation. How do I solve for x?
Add 5.
Add 5.
And then divide it by 2.
Boom. Then divide by 2. We should get x is 43. How do you feel about that?
Great. That's good.
It's like the first problem on your test on Friday. Boom.
Oh my god.
The test is on
I
Friday.
think I just started.
Okay. Let's look at number 4. Number 4. An initial deposit is invested at 6.5% interest, compounded annually. How long will it take until the balance grows to $400? Write an exponential equation first. That's my first step for you. Write an exponential equation first. What's my y-intercept or my a value? 200. Is my money growing or decaying? Growing, so I have to do 100% plus 6.5%. And then I have to move my decimal place. So I need to move my decimal place to get the b value. $1.065. 1, 2. So that means my b value is 1.065 to the power of x. It's asking us, how long will it take till the balance grows to $400? The balance.
What if we put 400 for what? Y?
400 for y or x?
X. Oh, Y.
Y. Our input is x, and that's time in years. Our output is money. So I'm going to say 400 equals 200 times 1.065 to the power of x. And now we're going to solve it. Do we subtract 200? How is 200 stuck to my multiplier? It's timesing, so we divide. We're going to divide first. Good. Divide both sides by 200.
Oh, I know how to do this.
What's 400 divided by 200? 2. Now what? What did we just learn about that we could change this to? The log. What would be the base of the log? 1.6065.
I have no room.
I know. We'll skip the iPhone question. You can write over 5. What's going to go into the log? 2. And what's going to come out? Great. So now we can type that in our calculator. Get our answer. How many years will it take? So what do we type in our calculator? We type the log of what's inside divided by the log of the base. That's how you change your base. How many years will it take to get $400? 11. We're doing the log of 2 divided by, oh no, I forgot my parenthesis.
Go press back.
I know. Yes, ma'am. See, this is why I'd rather use Desmos. Parenthesis divided by.
Wait.
Yikes. 1.065. So close, so close. Boom! Around 11 years. We did it.
Okay, I'm taking on it.
Great, here comes your homework.